All right, for example one, same idea. I have this polynomial and I'd like to factor it, so I went to Desmos and graphed it, and I'm looking at the x-axis to see where the equation is 0, and I see 3 places. Okay, so this is x is equal to 4, no problem there. Here we have x is equal to 0.5, so I'll write that as a fraction. Writing it as a fraction will help me write it better as a factor instead of using a decimal, okay? And then, well, this one doesn't line up nicely, but I mean, it said it was about negative 0.333. I mean, I'm gonna guess that's probably negative a third. But like in general, if you get a decimal and you don't know what its corresponding fraction is, like that could be a little bit of a problem. So I'm just going to assume that that's the case here. Like I'm not sure what it is, but there should be some way to figure out what it is equal to. So there's a little trick that you can use with any given polynomial that you're trying to factor. And it again comes from looking at the 4 and looking at the 6, the very first number and the very last number in terms of the degree. So what you can do is you can take these two numbers and you can list out their factors. So like the factors of 4 are 1, 2, and 4, and the factors of 6 are 1, 2, 3, and 6. We'll see why this is useful in a second, but we're just for now saying like, okay, there's this other 0, I'm not sure what it is because I got a decimal that I'm not confident about. But the other two factors are okay. I know it should be x minus 4. And again, I'm choosing to write it as 2x minus 1. So the denominator goes in front of the x and the 1 goes by itself. They're both negative because the x values are positive. So if we're going to factor this polynomial, it should be x minus 4. It should be then times 2x minus 1. But then, well, something else. There's got to be, something times x plus or minus a number. So it's like you're trying to fill in the gaps. Like what goes here? What goes here? But like we've said before, the numbers in front of the x's have got to multiply to 6. So like over here, I listed out 6. The only numbers that you should guess to put in front of the x should be 1, 2, 3, or 6. Like you wouldn't guess 5. 5 would actually be a pretty bad guess. There's no way that if you put a 5 here, that 5 times 2 times 1 is going to give you a 6. The only logical choices are factors of 6. So like if you're having trouble, a good place to start would be to take the 6, list out the factors, and then take the 4 and list out the factors. This is going to narrow down what the guesses are. The thing that should go in front of the x, it's got to be 3. I'm going to fill that in. So I'm going to erase this question mark. We'll get rid of that. I know it has got to be 3, so let's put 3x. So the reason is that 1 times 2 times 3 is in fact 6. That's how I'm getting a 6x cubed. So I basically looked here. I was like, oh, 3, it's perfect. I'll use it. I don't need any other number. Okay, now I'm left deciding, well, what goes over here? The product of the 4, this 1, and whatever this number is, has got to multiply to give me 4. In fact, positive 4. I see there's 2 negatives, so it's got to be that it's a positive, and the only numbers I should even consider choosing are coming from factors of 4. It's got to be 1, 2, or 4. If I pick something else, there's no way I could multiply to 4. It turns out that it's going to be 1. So I'll put a positive 1 here. And everything matches up perfectly. If I check the coefficients, again, a 1x, a 2x, and a 3x multiply to give me the 6x cubed. The negative 4, the negative 1, and the positive 1 multiply to give me the positive 4. And furthermore, the fact that this is 3x plus 1 means my initial thought about the 0 being a third was in fact, negative 1/3 is correct. So like if you're stuck and you're not sure what a certain factor is, you can always go to factors of numbers that appear within your equation to at least help narrow down your guess. So for this last example, same idea. I want to factor 36x cubed plus 117x squared plus 62x minus 35. So again, I went to Desmos, I looked at the graph, I'm narrowing in on the zeros because that's all I care about, and I see there's 3 spots. And again, it's going to tell me approximately what the decimals are. So one, it said 0.3333. That was for this very first positive one here. For this next one, it was negative 1.25. It's not too hard to make a fraction, but for this last one, I got like negative 2.333. And I was just, not confident about what the fractions are that correspond to every single one of these decimals. I'm sure you could figure it out at some point. But again, if you're trying to speed up that process, I'm going to look at the negative 35 and this 36 and think about factors of those numbers. So I'm going to actually list them out, even though you do not have to do that. So I'll start with the 35. The factors are 1, 5, 7, and 35. Of course, you could have negatives too, but for 36, okay, there's a lot more here. Let's see, we have, 1, 2, 3, 4, 6, 9, 18, and 36. So some numbers will have a ton of factors, but you can list them out if you'd like to. So if we think about how this thing factors, I know there's going to be 3 pieces because there's 3 distinct zeros, and all of the exponents are going to be to the first power. All right, so it's got to be, some number times x, some number times x, some number times x. I'm going to start with this very first one, which corresponded to this. If I was to guess a fraction that this is equal to, we kind of encountered this before, but it would be 1/3. But that makes sense, right? We have a 1 for this factor, we have a 3 for the second one, so having 3x minus 1 is a possible choice. The number that goes here, eventually for all the x's, has to multiply to 36. So choosing 3 will work. The numbers that go at the end are going to multiply to 35. I mean, 1 will always work, but it's also on our list. So now what about here, this negative 2.3 repeating? Again, we're looking for some fraction that will give me that decimal. So it's got to be something over 3. So like maybe 5/3 or 7/3 or 35/3. If I try 7 divided by 3, it actually gives me exactly what I want. So the numbers are actually showing up in here. So that is 7 divided by 3, negative 7 divided by 3. So let's see, I'd have to have 3 and then plus 7. And this is going to work because a 3 times a 3 will give me a 9, and then there's going to be something left over to take me to 36. And this negative 1 and positive 7, well, multiplying those will still take me to 35. Last thing I have to do is just figure out what goes over here. Now, it has to correspond to this 0, but I think we can just plug in what the correct numbers are. 3 times 3 is 9, and 9 times 4 is going to be 36. Notice that 4 appears in these factors. So I'm just going to place a 4 here. If I want to multiply to 35, negative 35 is going to be negative 1, positive 7, a positive 5 is what is left over. Notice that the 5 appears in the factors of 35, so I'll put plus 5. And if you check it out, this last factor has a 0 at negative 5/4, and that corresponds to the decimal that we currently have, negative 1.25. Well, the final answer is going to be this expression here. And all this did was come from looking at the zeros. I wasn't exactly sure of every fraction, but I used some of the numbers in the original polynomial to help me reason out what they must be.